Welcome to a lesson with Dr. Powell. Let's take a look at how we can graph a polynomial function that's been factored. So suppose we have something like f of x is equal to negative 3x times x plus 2 quantity squared. And then maybe let's do times x minus 3 quantity cubed. All right, so let's take a look at this. Let's notice when the output of this function is equal to 0. That's the same thing as saying the y value, which is the output, is equal to 0. So on the graph, we'll actually know that we'll have a few points, which will be on where y is 0, which is precisely the x-axis. So what x values make this 0? Well, if something's equal to 0 and you're multiplying, then that means one of the factors must be 0. So in this particular case, if this is 0, that means x is 0. So you know 0 is one of the places. Here, negative 2 makes that 0. And here 3 makes that 0. So these are called the zeros of the function, if you will. What makes the y value 0? Negative 2, 0, and 3. Okay, now let's think about end behavior. How do polynomials grow very much as x gets big, either way up or way down, or they'll go as x gets very big. So what we're going to do for that is we're going to think about the leading term. The term, when we multiply all of this out and expand it so it's not factored anymore, so, that has the highest power of x, because higher powers of x as functions do so much more and so much powerful in number and scope than anything with smaller powers eventually, and they just kind of win out. So they kind of rule out and become what we and tell us exactly what the end behavior will be. So to get that, we'd have to think about taking all the factors here and to find the leading term, or the biggest power. Basically, you find the biggest power of each factor, and you just multiply those together, and that'll be your leading term. So doing that, we have x times x times x times x times x, that's x to the 5th, times negative 3x, so negative 3x to the 6th. Now, what does this look like? Well, this guy right here is always positive, but then with this negative, it becomes always negative. In particular, it's the end behavior is going to be down, down both times, because it needs to get big and go in some direction. So this graph is going to be a down, down type behavior, end behavior. So that means when we start drawing the graph, we're going to start down and just come up to the first place where we hit 0. Now, what happens when we hit 0? We think, right? We look right here. You see this square? That means that the sign of this is not going to change when we're right around negative 2, because you're squaring. So it's kind of like have kind of a bouncing effect. And in some sense, when your x is close to negative 2, then this factor and this factor will roughly be stable, some kind of number. And so it almost will look like just a transformation of x plus 2 squared, or even x squared. So it'll be like almost look very closely locally like a transformation of x squared even. So it'll bounce, be like a parabola, bouncing right there, right at the negative 2, at least for a local behavior here. So up to negative 2 and it'll bounce. Now it's going to come back up when we get to 0. All right. When it comes back up to get to 0, what's going to happen? What is it going to look like? Well, same thing. It's going to look a lot like this factor multiplied by these guys, which will actually produce another negative to make this look something like something positive times x for a positive slope. It's going to look like a straight line nearly. So it's going to go through like a straight line, just like an x to the first power. Then what about as we come down to get here? It's going to look a lot like a transformation of a cubic. Now, cubic equation kind of flattens a little bit as it crosses. Oops. Okay, flattens a little bit as it crosses. And so it's going to look something like this. And notice, as we draw this, we have the proper end behaviors, just as expected. And we notice the sign of the graph. So we're negative, negative, and then for the y values are negative here. Y values are positive here, and you're negative here. Now, this will actually be a nice thing to remember and learn when we go forward in this class for other applications. Thanks for watching.